Today we're on page 3 of our chapter 13 notes packet, solving trig equations. And these trig equations that we're going to solve are going to be quadratic, but they'll all be factorable. All right. Yesterday we looked at solving trig equations that were linear. We had no sine squares or cosine squares. Okay, so this is the next step, solving trig equations that are factorable quadratic equations. Okay, so we can solve a second degree trig equations just like we solve algebraic equations. Remember, in the end, you must find the angles. Don't stop when you've solved for the trig function. For example, if we wanted to solve this quadratic equation for x, it's quadratic, so we would put it in standard form. We would subtract 1 from both sides here, and we would have x squared minus x minus 2 equals 0. And then we would factor. The factors of -2 that add to -1 are -2 and 1. So we'd factor this into x minus 2 times x plus 1 equals 0. Set each factor equal to 0. I usually skip that step and go right to the two values, x equals 2 and x equals -1. Now solve a similar second degree trig equation. Here we want to solve for all values theta, theta greater than or equal to 0, less than 2 pi. So we want to make sure we show our answer in radian measure. All right, we have sine squared theta minus sine theta minus 1 equals 1. So this is quadratic because of the sine squared. So we'll put it in standard form. We'll subtract 1 from both sides. Sine squared theta minus sine theta minus 2 equals 0. Lead coefficients 1 will go to the constant -2. The factors of -2 that add to -1 are -2 and 1. So this factors into sine theta minus 2 times sine theta plus 1 equals 0. Set each equal to 0. I think I'll show that part. And then solve. So sine theta is equal to +2 and sine theta is equal to -1. Right? And if you don't like working with keeping sine theta in the equation, then it's perfectly fine if you replace your sine thetas with x. All right? And then when you have your x value, then replace it with sine theta. Okay. So sine theta equals 2 and sine theta equals -1. Just going to write these over here. Now, so theta is going to equal the sine inverse of 2. But if we think of the graph of sine, y equals sine theta, the range, how high, how low and how high, isn't it just from -1 to +1? So there is no angle that has a sine value of 2. Well, let's just check it again, make sure we're in degree mode. Okay. So if I do second sine of 2, the calculator gives me an error. Right? There is no angle. Sine theta is equal to -1. Now, remember, when you get sine or cosine values of 1 or -1 or 0, think of your quadrantal angles, right? Think of the unit circle and 1, 0, 0, 1, -1, 0, and 0, -1. There you go, that last one, all right? If I was to key it into the calculator, I think it's going to give me -90. Second, oh, let me get out of that. 1 second sine of 1, yeah, give me -90, which is equivalent to an angle of -90 is equivalent to an angle of 270 degrees. Okay, so theta is equal to 270 degrees. And we want this in radian measure, so we multiply by pi over 180, and that's 3 pi over 2. So one value for theta in that first example. Next, we want to solve cosine squared theta is equal to 1. Well, there's two ways we can go about this. If you had x squared equals 1, one thing you might do is simply take the square root of both sides. All right, so that's what I'm going to do here. So if I square root both sides, we'll have cosine theta is equal to, don't forget, whenever we compose square root, it's plus or minus 1. Again, I'm getting positive and negative values of 1, so I'm thinking of the unit circle. And it wouldn't be a bad idea, although we went and wrote it above, let's write it again. That's 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Cosine value is the x-coordinate, right? So here and here. And this is 0 degrees and 180 degrees, and all the way around is 360. 0 degrees is equivalent to 0 radians, right? Because my theta has to be greater than or equal to 0, so 0 is fine. 0 radians. 180 degrees, which is pi radians. And then it has to be less than 2 pi, so it cannot include the 360 degrees or 2 pi radians. All right, so my answers here are 0 radians and pi radians. So there are two values for theta. For B, we have tangent squared theta equals negative tangent theta. Okay, so let's bring these over onto the same side. So I add tangent theta to both sides. So we have tangent squared theta plus tangent theta equals 0. Quadratic in standard form, it's not 3 terms, it's only 2. Look, there's a GCF, right? Factor out that GCF. Tangent theta is common, and inside parentheses, tangent theta plus 1. Set each equal to 0, so tan theta equals 1, and tan theta plus 1 equals 0. I'm sorry, tan theta equals 0, and tan theta plus 1 equals 0. Okay, tangent theta equals 0. And tangent theta equals negative 1. Now for tan theta equals 0, let me just move this over to here. All right, what angle or angles have a tangent value that are equal to 0? Well, I've got the unit circle here, right? And tangent, sine over cosine. So sine over cosine, 0 over 1 is 0. So this would be 0 degrees, and I know I've got to convert to radians, right? Sine over cosine, that would be undefined here at 90 degrees. Sine over cosine 0 over negative 1 would be 0, so that's 180 degrees again. And negative 1 over 0 is undefined. And I know we can't go all the way around to 360 because our theta has to be less than 2 pi. All right, now tangent theta is equal to negative 1. Okay. So tangent is negative. We don't get any negative ones out of here for tangent. So this is where we're going to use the calculator. All right, tangent is negative in quadrants, all students take chemistry, in quadrant 2 and quadrant 4. So our reference angle would equal tan inverse of 1. Okay, so we go second tan, 1, 45 degrees. So our reference angle is 45 degrees. In quadrant 2, 180 minus 45 is 135. And in quadrant 4, 360 minus 45 is 315. And now, yes, we have to convert these to radian measure. All right, so multiply by pi over 180. 45 goes into 135 3 times, and into 180 4. So that's 3 pi over 4. And for 315, multiplying by pi over 180, that's 7 pi over 4. All right, so here are two values for theta, and then here are 0 and 180. 0 is equivalent to 0 radians and 180 to pi. So here we have 4 values of theta that would satisfy the equation. And if you could pause the video and try the next 4 problems on your own, solving for all values of theta, theta greater than 0, greater than or equal to 0, and less than 2 pi radians. Okay, this is quadratic, so I'll put it in standard form. First, I'll subtract 1 from both sides. I'm not showing that step. I get 3 tangent squared theta minus 3 equals 0. I'll factor out the 3, and we get tangent squared theta minus 1 equals 0. Then we would have to factor this. And going about this, I've changed my mind, all right? I'd prefer to rather get 3 tan squared theta by itself and then square root both sides, but I started this way, so let me continue. Factoring, this is the difference of 2 perfect squares. This is dots, right? So we have 3 and then tan theta plus 1 times tan theta minus 1 equals 0. We said each equal to 0. 3 equals 0 just isn't a true statement, so just cross that off. Tan theta plus 1 equals 0. And tan theta minus 1 equals 0. So we have tangent theta equals negative 1 and tangent theta equals positive 1. Okay. Well, the nice thing is our reference angle, right? Our reference angle is going to be the tan inverse of 1, which we just did on the other side and still on my calculator. So it's 45 degrees. So we have a 45-degree reference angle. And for negative, tangents negative in what quadrants? Quadrants 2 and 4, and tangents positive, or positive 1, in quadrants 1 and 3. Okay, so a 45 reference angle in quadrant 2 would be equivalent to a 135-degree angle. In quadrant 4, that would be 360 minus 45, which is 315. In quadrant 1, it would be its own angle. And in quadrant 3, it would be 180 plus 45, which is 225. So here we have our 4 angles, all in degree measure, convert to radians, timesing by pi over 180. That would be pi over 4 radians for the 45 degrees, right? 225. 225 divided by 180. Math bracket. 5 pi over 4 the 135 timesing by pi over 180, just squeezing it in there. That's 3 pi over 4, and 315 7 pi over 4. And there we have 4 values for theta. Number 2, I'm sorry, the other way I would have done this, let me just go back to this. If I added 2 to both sides, I would then have 3 tangent squared theta equals 3. Divide both sides by 3, tangent squared theta equals 1, and then square root both sides. Tangent theta would equal plus or minus 1. So that would have been the other way. We'll still come up with the 2 values for tangent theta. Now, number 2, don't ever, ever, ever divide by a trig function. All right? Do not divide by cosine theta. No, that's not what we do. If this was 2x squared equals x, did we ever divide by x? No. Simply subtracted x from both sides and then went about factoring. Same thing here. Subtract cosine theta from both sides, and we have cosine squared theta, 2 cosine squared theta minus cosine theta equals 0. Now factor. There's a GCF, cosine theta, times 2 cosine theta minus 1 equals 0. Set each one equal to 0. Okay, so cosine theta equals 0. I know I'm going to look at my quadrantal angles for that. Add 1, divide by 2. Cosine theta equals 1/2. All right, positive 1/2. Now, back to cosine theta equals 0. That's an x value of 0, right? So that's my 90 degrees, or pi over 2 radians. And my 270, or 3 pi over 2 radians. So pi over 2 and 3 pi over 2. 2 values there. Cosine theta equals 1/2. So our reference angle is going to be the second cos, or cosine inverse, of 1/2. Second cos, 0.5, 60 degrees. So a 60-degree reference angle. This positive 1/2, cosine is positive in quadrants 1 and 4. So the 60-degree reference angle is its own angle in quadrant 1. In quadrant 4, that would be 360 minus 60, which is 300 degrees. And convert to radians, multiply by pi over 180. That would be pi over 3. And 60 goes into 300 5 times, 5 pi over 3. 4 values. Number 3, quadratic, put it in standard form, subtract 3 from both sides. That's going to get us 2 cosine squared theta plus cosine theta minus 1 equals 0. This is a quadratic, but the lead coefficient is not 1, it's 2. So if we multiply 2 times the constant -1, that's -2. The factors of -2 that add to 1 are +2 and -1. So remember, this is a middle step. We multiplied by 2, so we need to divide by 2. 2 cosine theta plus 2, and 2 cosine theta minus 1, and 2 divides into 2 cosine theta plus 2. It goes into cosine theta plus 1 times 2 cosine theta minus 1 equals 0. All right, you set each equal to 0. and solve for cosine theta. I'm skipping the setting equal to 0, going right to cosine theta equals -1, and cosine theta equals +1/2. Cosine theta equals -1. Well, I'll go back up to number 2 there, and cosine of theta equals -1. That is for our 180-degree angle, right? Or pi radians. And cosine theta equals 1/2. We already found that from number 2 above. So let's just give those answers of pi/3 and 5 pi/3. Save us some time here. And there we have our 3 values for theta that would satisfy this equation. Okay, and the last one here on this page, we have cosecant. Well, standard form, let's subtract 5 from both sides. So cosecant squared theta minus cosecant theta minus 2 equals 0. The factors of -2 that add to -1 are -2 and 1. That lead coefficient was 1, so we were able to go right to the constant there and find those factors. So cosecant theta minus 2 times cosecant theta plus 1 equals 0. Set each equal to 0 and solve. Cosecant theta equals 2 and cosecant theta equals -1. Now, take the reciprocal of both sides, right? The reciprocal of cosecant is sine. So sine theta equals 1/2. Reciprocal of 2 is 1/2. And sine theta equals reciprocal of -1 is -1. Again, I see the sine theta value is -1. I'm thinking of our unit circle, right? Sine, or y value of -1, is at 270 degrees, or 3 pi/2 radians. So theta here is equal to 3 pi/2. Now, for the sine theta equal to 1/2, that over there, that's a positive value. So we're looking in quadrant 1 and quadrant 2, and I just happen to know that the wood angle measure has a sine of 1/2, that's 30 degrees. If I check on the calculator, sine inverse of 0.5 is 30 degrees. So our reference angle is 30 degrees, which would be its own angle measure in quadrant 1. And in quadrant 2, we're looking at 180 minus 30, which is 150. Convert these to radians by multiplying by pi/180. 30 goes into 186. So I'm just reducing. So that's pi/6 radians and 5 pi/6 radians. And let me go back and circle. There we go. So 3 values for theta. This concludes our video for today. Thank you.